The overall goal of this procedure is to use liquid chromatography selected reaction monitoring, or LC-SRM, to quantify the absolute abundance of target proteins within complex biological samples. Following selection of peptide targets, crude external peptide standards are synthesized and used to develop SRM assays using liquid chromatography mass spectrometry, or LC-MS. The resulting assays are used to perform qualitative LC-SRM analysis of prepared biological samples. If the biological sample-derived target peptide is detected, the biological samples are analyzed using quantitative LC-SRM assays by adding a stable isotope dilution series of internal peptide standards. Ultimately, LC-SRM can be used to accurately quantify proteins from a wide variety of biological samples and to support investigations of a wide variety of protein targets.
The main advantage of this technique over existing methods, like immunoassays, is that the assay development is relatively quick and inexpensive, and the resulting assays are amenable to multiplexing and not vulnerable to antibody cross-reactivity.
To begin, prepare lyophilized peptide standards as described in the text protocol. Then, add 100 microliters of formic acid acetonitrile solution to each nanomole of lyophilized peptide standard to produce a peptide concentration of 10 micromolar. Vortex the samples for 2 minutes and bath sonicate them for 5 minutes to ensure that peptide dissolution is complete. Pull the dissolved peptides and concentrate the resulting mixture in a vacuum concentrator to a final volume of 80 microliters. Add 20 microliters of acetonitrile to dissolve any precipitated peptide. The sample now contains 10 micromolar of each peptide as well as 20% volume-to-volume acetonitrile and can be used to prepare the internal and external peptide standards. Analyze the mixtures of the external peptide standards at approximately 1 to 10 picomoles of each peptide per injection by shotgun mass spectrometry using a nanoflow HPLC system coupled to a triple-quadruple mass spectrometer as detailed in the text protocol. Ensure that each LC-MS run includes a 60-minute linear gradient, a column regeneration step, and a column reequilibration step. Analyze the resulting shotgun data using database searching against the sequences of the external peptide standards. Manually review all of the peptide identifications to ensure that they are all unambiguous, discarding any ambiguous peptide identifications. Use the shotgun MS peptide identifications to construct a spectrum library using a software program such as Skyline. Prepare an LC-SRM transition list using the 3 to 10 most intense transitions per precursor ion. Use the resulting transition lists to perform LC-SRM analysis of the mixtures of the external peptide standards. Manually review the resulting LC-SRM data and delete any poorly performing assays. To prepare the biological samples, first harvest the cells as described in the text protocol. Add 400 microliters of freshly prepared urea lysis buffer and mix each sample using gentle pipetting. Transfer each sample to a 2 milliliter tube that has a screw cap with an O-ring containing approximately 100 microliters of 0.1 millimeter zirconia silica beads. Lyse the cells by vortexing the samples for 5 minutes at full speed. Bath sonicate the samples for 10 minutes at room temperature to assist homogenization and protein denaturation. Then, perform a protein concentration assay of the lysates, such as a bisynchronic acid assay. For qualitative analysis, prepare 4 200 microgram aliquots of cell lysate for a stable isotope dilution series. Add the stable isotope dilution series of the equimolar mixture of the internal peptide standards to the samples. Reduce protein cysteine residues by adding 0.7 microliters of 1 molar DTT to each sample and incubating the samples at 60 degrees Celsius for 30 minutes. Alkylate protein cysteines by adding 7 microliters of buffered iodoacetamide to each sample and incubating the samples at room temperature for 20 minutes in darkness. For each of the samples, add 482 microliters of 100 millimolar HEPs, adjusted with sodium hydroxide, so that the final urea concentration is 1 molar. Next, tryptically digest the proteins into peptides. Add 8 microliters of 0.5 micrograms per microliter sequencing grade modified trypsin to each sample that contains sal lysate. Then, incubate the sample at 37 degrees Celsius for 18 hours. Following incubation, add 440 microliters of 2% volume-to-volume formic acid. Centrifuge all of the samples at 21,000 G for 20 minutes at room temperature to pellet any precipitates that would clog a C18 SPE cartridge. Solid phase extract each of the supernatants using a disposable C18 SPE cartridge. First, wet the column by applying 1 milliliter of buffer B and equilibrate it by applying 1 milliliter of buffer A twice. Force the mobile phases through the C18 SPE cartridge using a flat-surfaced rubber bulb and an extraction manifold. Apply the sample and subsequently wash the cartridge with 1 milliliter of buffer A twice. Elute the peptides by applying 1 milliliter of buffer B slowly. Concentrate each eluate in a vacuum concentrator to a final volume of 100 microliters to evaporate away the acetonitrile. Then, add 2 microliters of 5% volume-to-volume formic acid in acetonitrile to each sample. Analyze the samples using qualitative LC-SRM as before. For quantitative LC-SRM analysis, run the isotope dilution series of each biological sample. Shotgun mass spectrometry was used to analyze the external peptide standards. The top 10 most intense transitions per precursor were selected for LC-SRM. LC-SRM was then used to analyze the external peptide standards. The resulting peptide identifications should be unambiguous. Qualitative LC-SRM analysis of the biological samples typically resulted in more background signal, but most of the peptide targets were confidently identified. Quantitative LC-SRM was performed using internal peptide standards spiked into the biological samples. The resulting protein abundance values were consistent across the biological replicates and the 2 target peptides per target protein.
After watching this video, you should have a good understanding of how to develop and perform LC-SRM assays to quantify the absolute abundance of target proteins within complex biological samples.